Namaste everyone. Welcome to the class. Let us start with exercise 8.1. The first question is the angles of quadrilateral are in the ratio 3, 5, 9, 13. Find all the angles of quadrilateral. So here these kind of questions are generally asked for 1 marks. So for 1 marks it is not required to write in too detail. Now the angles of quadrilateral are given in ratio 3, 5, 9, 13. So I will say that let you can write given, okay, no problem. Okay, you can draw the diagram also. So the diagram will be something, it will be something like this. This angle is representing ratio 3, this is ratio 13, this is somewhat ratio 9, and this should represent ratio 5. So it should be something like this. Okay, A, B, C and D. Okay, I will say that given in quadrilateral ABCD, angle A ratio angle B ratio angle C ratio angle D is equals to 3 ratio 5 ratio 9 ratio 30. To find, we have to find the values of angle A, angle B, angle C, angle D. Solution. So what I will say, that ratio is given, so I will say let common multiple Bx. Now you understand that what I mean to say about common multiple. When ratios of angles are given, that means the angles are, okay, some multiple of these numbers 3, 5, 9, 13. Okay, the number could be 2 times 3, 5 times 2 times 5, 2 times 9, 2 times 13, or any other number. So there will be some common multiple. So I will consider let the common multiple be x. So therefore my angles will become, angle A will become 3x, angle B will become 5x, angle C will become 9x, and angle D will become 13x. Now next, I know that sum of all angles of quadrilateral is 360 degree. So I will say that angle A plus angle B plus angle C plus angle D is equals to 360 degree. And reason, if you want to write, you can say that sum of all angle of quadrilateral. So therefore the value of angle A is 3x, angle B is 5x, angle C is 9x, angle D is 13x. So they all together will be 360. You add 3 plus 5, 8, 8 plus 9, 17, 17 plus 30, 13 is 30. So 30x is 360 degree. So this gives me the value of x as 0, 0 will cancel, 3 1 the 3, 3 2 the. So x is 12 degree. Therefore, the value of angle A is 3 into 12 degree, that is 36 degree. Angle B will be 5 into 12, that is 60 degree. Angle C will be 9 into x, 9 into 12, that is 108 degree. And angle D is 13 into x, 13 into 12 I will say, 13 into 12. So 12 3 the 36, 3, 12 1 the 12, 12 plus 3 15. So this is 156 degree. So these are the angles A, B, C and D. Okay, second problem. If the diagonal of parallelogram are equal, then show that it is a rectangle. Now parallelogram, we have given that if diagonals are equal, then it is a rectangle. So You can draw this diagram as a rectangle itself, because ultimately I have to prove that this is rectangle and diagonals are equal. So when you try to draw a parallelogram with equal diagonal, you will get something, a rectangle figure. So in a parallelogram, when it become a rectangle, when its one angle is 90 degree. So you have to prove that any of the angle of this parallelogram is 90 degree. So I name it ABCD. ABCD is a parallelogram in which diagonal AC and BD are equal. So here I will say given quadrilateral ABCD is a parallelogram, and one more thing is given, that AC is equals to BD. This is given. We have to show or to prove, I will write, to prove that this quadrilateral ABCD is rectangle. Now in proof, we have to show that this ABCD is a rectangle. So how we proceed? Now see, if I take triangle DAB and triangle CBA, then in these two triangles, side ADBC is equal, side AB is common, and AC and BD equal, it is already given. So I can prove that they are congruent triangle. Now as they are congruent, their corresponding angle, that is angle A and angle B, they are also going to be equal. Now as ABCD is a parallelogram, angle A plus angle B will be 180 degree, as angle A and angle B, they are interior angle, okay, formed by two parallel lines and their transversal. So interior angles are supplementary. So sum is 180 degree and each angle means both the angles are equal. So when you calculate, you will find each angle is half of that 180, which is 90 degree. So as I get angle A 90 degree, angle B 90 degree, I can say that angle C and angle D in the same way will also be 90 degree, and this ABCD is a rectangle. This is how we have to proceed. So let us start. In proof, I will say that in triangle DAB and triangle CBA, I have this DA is equals to CB. I have this AB equal to AB, and I have this AC, or here it will be, I will say that BD. Okay, on left hand side we have taken triangle ADAB. So this BD is equals to BD is equals to AC. Therefore, I will say that this triangle DAB is congruent to triangle CBA. Okay, side criteria. Okay, now this is proof. The triangle DAB is congruent to triangle CBA. This is SSS criteria. So their corresponding parts, that is therefore angle DAB, I will take angle DAB, will be equal to angle CBA. This is corresponding part of congruent triangle. Okay, you can consider this as equation 1. Also, I will say that angle DAB plus angle CBA. Now this angle from this diagram, DAB and CBA, their total is 180 degree. 180 degree. You can give here reason that interior angle, I can say interior angle theorem better. Interior angle theorem. Interior angle theorem is that if two lines are parallel and transversal, there is a transversal, then the interior angle formed are supplementary. So interior angle theorem. This is equation 2. Now from 1 and 2, I can say that from 1 and 2, as sum is equals to 180 and both are same angle, so I will say that from 1 and 2, this angle DAB will be equals to angle CBA will be equal to half of this 180, that is 90 degree. Okay, so as one angle of the parallelogram I proved as 90 degree, I will say that therefore this quadrilateral ABCD is a rectangle. Next question. Show that if the diagonal of quadrilateral bisect each other at right angle, then it is a rhombus. Now, nothing, no parallelogram, nothing. Some kind of quadrilateral is given. Show that if the diagonal of quadrilateral bisect each other at right angle. And what is given? Ki diagonals are bisecting each other at right angle. Now, definitely, when diagonals are bisecting each other at right angle, I will get something like rhombus. So it is better that instead of drawing any type of quadrilateral, I draw a rhombus type quadrilateral. So this ABCD is looking like a rhombus. Now here, what is given? So given, I will say that given in quadrilateral ABCD, diagonal are bisecting each other. This I will take point M. In quadrilateral ABCD, we have given that this AM is equals to CM and BM equal to DM. So AM is equals to CM, BM equal to DM, and also we have given that this AC is perpendicular to BD. AC is perpendicular to BD. We have to prove, here we have to prove that this quadrilateral ABCD is rhombus. Now let us see the proof. Okay, let us copy this figure from here. This figure from here, somewhere here, so that it will be in front of us while doing the proof. Okay, so I have to prove that this is rhombus. That means I have to prove that all the sides are equal. Yes, we have to prove that all the sides are equal. Now, if I take a triangle ABM, here this is 90 degree. This is 90 degree. If I take triangle ABM and triangle CBM, then you can see that angle M is the same in both the triangle. It is 90 degree. AC and CM, they are equal, it is given, and BM is common side. So by side angle side, I can prove that these two triangles are congruent, and hence AB and BC equal. So better, let us start. I will say that in triangle AMB, now correspondence you have to maintain na? In triangle AMB, and proof in triangle AMB and triangle CMB, and triangle CMB. I take these two triangles. In these two triangles, we have AM, in triangle AMB and CMB, we have AM is equals to CM, angle AMB is equals to angle CMB. Here you can say that it is given. Here you can say that each angle 90 degree, or if you write given, then also it is okay. And this BM is equals to CM. BM equal to BM, sorry, BM equal to BM. Now BM equal to BM, they are common sides. Common side, I will say common side. So therefore, triangle AMB is congruent to triangle CMB, and reason is side angle side criteria. This is side angle side criteria. Triangle AMB and triangle CMB, they are congruent by side angle side criteria. So these two triangles are congruent. Therefore, I will say that side AB is equals to side BC. Okay. This is I will take as equation 1, and this is corresponding part of congruent triangle. I will say that similarly we can prove. Now as I proved that AB equal to BC, similarly we can prove that this BC is equals to CD is equals to DA, right? That is, I have AB is equals to BC, BC is equals to CD, CD is equals to D. Hence, this quadrilateral ABCD is a rhombus. Fine. Good question. Now fourth question, show that the diagonal of square are equal and bisect each other at right angle. Show that diagonal of square are equal and bisect each other at right angle. Now, what is a square? A square is a rhombus, or a square is a parallelogram with each side equal and each angle 90 degrees. So here I will say that given that this ABCD so that diagonal of square ABCD is square. Okay, ABCD is square, and we have to prove that diagonal of square are equal. First we have to prove, say if it is ABCD, then we have to prove that this AC is equals to BD. Diagonals have to prove that diagonals are equal. And next I have to prove that they bisect each other at right angle. This is first part. Second part, I have to prove that suppose if I take this as M, I have to prove that this AM is equals to CM and BM equal to DM. And third, I have to prove that this AC is perpendicular to BD. Okay. So these three things we have to prove. So proof, you can do this proof, okay, means quickly by considering that all the squares are rhombus, and the property of rhombus is that diagonals are perpendicular bisector of each other. So it is one line answer. Only you have to prove that diagonals are equal. Or if it comes for like 3 marks or 5 marks, then in that case, okay, don't assume the property of rhombus. You just prove it that AM equal to CM, BM equal to DM, and AC and BD, they are perpendicular. That is, angle AMB is 90 degree. Okay, so in proof, first I have to prove that this AC and this BD are equal. So for that, again I will take triangle TAB and CBA. So I will say that in triangle DAB and triangle CBA. Now here you can see that this is equals to DA is equals to CB, and this AB is common side. AB is equals to AB common. This is given. This is common, and angle DAB is equals to angle CBA, each 90 degree. So therefore this triangle DAB is congruent to triangle CBA. Again here we have side angle side criteria. So therefore, I have, now what I have to prove, that diagonals are equal. That is, I have to prove that this BD is equals to CA. BD is equals to AC. Okay. This is corresponding part of congruent triangle. So first part I have done. I have proved that this AC and this BD, they are congruent. Now second part, that we have to prove that this AM equal to CM and DM equal to DM. For that, what you can do, you can take two triangle AMB and CMD, and there by angle side angle, right, you can see that this angle A and this angle C, their alternate angle, they are equal. Angle B and angle D is also equal, and this CD and AB are equal because sides of a square are equal. So by again angle side angle, these two triangles are congruent, and hence their corresponding sides are equal. So by that we will be able to prove that this AM is equals to CM, BM equal to DM. Okay, so let us take that. Means if in case of square, means here it is asking square, but if it is not square, it is asking rhombus, there also you will do in the same way. So I will say that now in triangle AMB, in triangle AMB and triangle CMD, for angle A, the corresponding angle is angle C. Therefore, I am maintaining the correspondence. So in triangle AMB and CMD, we have angle BAM. Angle BAM is equals to angle MCD. BAM. So DCM. It is DCM. Again, I am writing angles also by using proper correspondence. Also, angle ABM. Angle ABM is equals to CDM, angle CDM. Okay, so this angle and this angle equal, and here we have this angle and this angle equal. The reason is alternate angle theorem. Why? They are equal. Alternate angle theorem. Also, we have side AB is equals to side CD. If you want to write reason for this also, you can say that side of a square. So sides of a square are equal. Side of square. I will say side of square. Fine. AB is equals to 3. Therefore, this triangle AMB is congruent to triangle CMD. Therefore, this AM is equals to CM and BM is equals to D. Okay, AM equal to CM, BM equal to D. Alternate angle side. Okay, so the second part also we have done. This is I will take as equation 2, and this is corresponding part of congruent triangle. Now third, I have to prove that they are perpendicular bisector. So for that, so whatever things you have to prove and you are proving, it is always better that with the help of pencil, you put them in box. When 2-3 things are required to be proved, then put them in box so that it is easy for you to identify as well as for your examiner also. Okay, so now I have to prove that each angle is 90 degree. So for that, I will take triangle AMB and CMB. So now I will say in triangle AMB and triangle CMB, AMB and CMB. Now here your AM is equals to CM AB is equals to BC, AB is equals to CB or BC, better CB, write CB, AB is equals to CB. This is from equation number 2. See, in equation number 2, AM equal to CM. This is given because it is square, and your side BM is common. So side BM is equals to BM. This is common side. So therefore, I will say that this triangle AMB is congruent to triangle CMB. AMB is congruent to CMB. Therefore, their corresponding angle, here it is side, side, side criteria. Therefore, their corresponding angle, that is angle A. Let us see if I can copy that. Yes. So, therefore, angle AMB is equal to AMB is equal to angle CMB. Okay, this is corresponding part of congruent triangle. Also, angle AMB plus angle CMB is equals to 180 degree. Okay, this is linear pair angle. Linear pair angle, right? So as the sum is 180 and they are equal, so therefore you can say that this angle AMB is equals to angle CMB is equals to half of this 180, that is 90 degree. So therefore, as this angle is 90 degree, this angle is 90 degree, therefore this AC is perpendicular to BD. So this is also proved. This you can take third equation. So we have proved that AM equal to CM, BM equal to DM. We have proved that BD is equal to AC, and we have proved that AC is perpendicular to BD. Hence, finally, I will say that hence proved. You can write all these three statements together here. Okay, now let us see the next question, sixth question. Diagonals AC of the parallelogram ABCD bisect angle A. Show that it bisect angle C. Okay, so it is given that for parallelogram ABCD, diagonal AC is bisecting angle A. We have to prove that it will bisect angle C also. Okay, so here given two things we have to prove, and second we have to prove that this ABCD is a rhombus. So given quadrilateral ABCD is a parallelogram, and second given is that angle DAC is equals to angle BAC is equals to, I will take X. Okay, say in bracket I will write, let us say that these two angles are equal and each angle is X, right? This will help me to prove. Now we have to show, or I will say that we have to prove that first we have to prove that AC bisect angle C, and second we have to prove that this ABCD is a rhombus. Now if you see this diagram, this angle BAC and this angle DCA, they must be equal as they are alternate angle formed by two parallel line and transversal. So this is X, so here I will get X. Similarly, AD and BC parallel, so I will get angle DAC is equals to BCA. So they are also going to be equal, so this is also X. So here this angle DCA is X, BCA is X. So therefore they are equal, and I will say that AC bisect them. Simple. Then I will take triangle ABC. In this triangle, the value of angle BAC and value of angle BCA, they are both X, so that is equal. So their opposite sides are equal, that is AB equal to BC. So in parallelogram, if adjacent sides are equal, it is a rhombus. So this is how we prove that it is a rhombus. So let us write all these things, okay, what we discussed. Proof. So here I will say that angle BAC is equals to angle DCA. Now BAC we have taken x, so this is equals to x. And here reason, okay, I will consider this as equation 1, and reason I will write alternate angle theorem. Alternate angle theorem. Second, in the same way, we can say that angle DAC also, in the same way, we have angle DAC is equal to BCA is equals to angle BCA. This is also equal to x, and the reason is same, alternate angle theorem, AAT. But you write complete now, alternate angle theorem. This is your second equation. Now from 1 and 2, we have angle DCA is equals to angle BCA. So angle DCA is equals to angle BCA is equals to x. Therefore, I will say that this AC bisect angle C in quadrilateral ABCD. Okay, so this is first part we have done, AC bisect. Okay, now second I have to prove that it is rhombus. So I will take triangle ABC. So I will say that okay. So I will say that now in triangle ABC, angle A is equals to angle C is equals to x. This is from 1 and 2. Okay, in 1 and 2 we have seen that this angle is x and this angle is also x. So angle A for triangle ABC, angle A is x, angle C is x. So therefore their opposite sides, that is therefore for angle A opposite side is BC, will be equal to AB. You can say that opposite sides of equal angle. Opposite sides of equal angle, or you can also write converse of isosceles triangle theorem. So BC is equals to AB. So two adjacent sides are equal. Therefore, this figure ABCD is a rhombus. Right? Simple. Quadrilateral ABCD is a rhombus, we have proved. So let us stop here and see other questions in our next class. Thank you for being with me. I always motivate you to solve all these problems by yourself. So first you must try yourself, and then you should see how I have done. It may possible that you will do the problem in a much better way than what I am discussing with you here. Thank you.